Good afternoon, friends. Let's get started. We are in the middle of Scala and Spark. Let me start recording the WebEx session. So far what we have seen, we have get into Scala a little bit, and once we understand Scala a little bit, we started working on Spark, and so far we have created a simple word count program. And now when we actually looked into the jobs after running the word count program on the cluster, let me go back to the Spark job history server, and we have the question why it actually started, uh, why it actually creating 270 tasks. So let me go back here to Spark job history server. Actually, I need to go to Ambari. So I'm going to Ambari here. So if you go to Spark history server, let me see. Okay, let me actually start the job. Then we'll start. So here I'm connecting to the cluster. Okay, I don't have. Okay, let me run it again. So we are talking about the word count program, which we compile into jar file, and let me copy to the lab again, and then we will see. Okay, meanwhile, let me go on to go to labs.itversity.com and get my credentials. And now let me copy this jar file, scp target scala wc, and then so now the jar file is copied. Okay, now I'm on the lab, and I can actually, so to see the contents of the jar file, you can also run this jar tvf command. Most of you are Java developers, and you might be familiar about this. If you are not familiar, to get the class names, you can also run jar tvf command, and then get the class name. Our class name is just wc. Okay, so now I can say spark submit. and then class WC. Sorry. And then I want to run. Let me uh, increase num executors. Num executors 5, and then I just have to give the jar file name. And it takes 3 parameters. One is the input path, which is public. Let me see which parameter is that. Okay, so I'm closing. I'm in another project. I am closing that, and here I'm going to WC project, and it takes actually three parameters. This one is input path. Output path is the next parameter, and third one is which mode we want to run, dev or production. So here I have to give public random text writer, and the output path is user D Gadiraju WC 0P1 and prod. And also we want to run in yarn mode. So here we have to give master yarn. Okay, and hit enter. Now the job is started. Go to the tracking URL. And paste that URL. And you see here, the program will execute in two stages. And the first stage will run in 270 tasks within that 5 executors. So each executor will approximately run 54 tasks. And even second stage is 270. So first we will see why this 270 is, and then we will understand about this probably today or a little bit later. Okay, so to understand this logic, especially when the program is running yarn mode, to understand why it take 270 tasks, you need to understand HDFS little bit in detail. So when we actually run spark submit command, what is the input path we are giving? We are just saying /public /random text writer. So yeah, here if you see, this is nothing but it's a its input path, and by default, when especially when you use tools like distributions like Hortonworks, by default the location will be HDFS, because HDFS and Spark will be integrated. Okay, so here, as this is the path in HDFS, we need to understand the logic, some details within HDFS, and then we will be able to understand why it is creating 270 tasks. Here I am logging into gateway node using one more session. So this one is still running the job. It will take some time. Meanwhile, I am opening another session. Okay, I am connecting to gateway node. So it seems someone is asking a question. Okay. Also, let me start the record. Yeah, record is already going. So we are good to go. So here I have opened another session, and before actually getting into HDFS and start understanding more about HDFS, you need to understand a command line utility called Hadoop. Okay, if Hadoop is installed, if the binaries are there on the gateway node, then when you type Hadoop and hit enter, it will give you list of valid subcommands within Hadoop. So unlike Spark, where you type Spark shell and it will take you to REPL, Hadoop is not actually kind of REPL. Okay, it's just a command which can issue some commands related to Hadoop. To deal with, so when as we are talking about HDFS, what is HDFS? HDFS is nothing but Hadoop distributed file system. Okay, so here this file system can be in short called as FS. So if you want to deal with file system within Hadoop, the main command related to file system is FS. So there are several other commands under Hadoop. One is FS, other one is version to get the version of Hadoop you have, jar to submit the MapReduce jobs, which is not relevant for today's discussion, or we will not be discussing in next coming weeks also. We will see very late. After Spark is done, probably we will see a little bit on jar. And then few other commands which we don't want to explore at this time. The only thing which we are interested in is FS. Okay, and FS stands for file system. So you can, if you want to do anything with file system, and if Hadoop is set up on your PC or on the cluster, then Hadoop FS will give bunch of subcommands which starts with hyphen, and there are these many commands which will typically deal with file system. So let's randomly pick some commands. Okay, let me pick mkdir. So what is mkdir? Means make directory. So if you want to create directories within HDFS, we use hyphen mkdir. If you use hyphen ls, so if you are familiar with Linux, to list files you just say ls, right? And if you want to list files within HDFS, then you have to run Hadoop FS hyphen ls. Okay, and then you can give your home directory just to get started. Even if you do not specify the path and run Hadoop FS hyphen ls, it will by default look into this location. Okay, so that is nothing but a HDFS path, and every one of you actually have a OS user similar to your account, lab account. Okay, so either you can give Hadoop FS hyphen ls the home directory like this, or you can also delete like this. Both are same, and hit enter. It's ls. Okay, and you can see bunch of files in my home directory. Okay, and output looks like this command ls hyphen ltr. If you are familiar with Linux, ls minus ltr, minus l is to list the files, t by time, r is to means list the files with all the details, t sort based on time, and r sort in reverse order. So the latest file will come at the bottom. Okay, so if I run ls hyphen ltr, you can see the latest file came at the bottom. If I just run ls hyphen lt, ls hyphen lt, the latest file will come at top. Okay, if I just say ls hyphen l, then the files will be sorted alphabetically on file name. But hyphen l will make sure the files are listed with permissions, owner, group, size, date, etc. Okay, so ls hyphen ltr is the most frequently used ls command, where you get actually details about your files, sorted the files by time with the latest one at the last. Okay, and Hadoop fs hyphen ls, ls hyphen ltr is actually getting us the local files, okay, which are on gateway node, whereas Hadoop fs hyphen ls, when we run this command, it will actually get the files which are in HDFS. Okay, we will see what is the HDFS in a moment. And this is the one of the most confusing part especially people who are not from the Linux background, they confuse between local file system and HDFS. So when I run ls-ltr, it gives the local details about the local files. And when I run Hadoop fs -ls or Hadoop fs or any subcommand after Hadoop fs, it's actually dealing with HDFS files. Okay, and now if you see, if I give ls-ltr user d gadiraju, it will not work because there is no such directory or file in the local file system. But when I run Hadoop fs -ls, as it is going to HDFS, it is getting files for you. Okay, so here I will give a minute or two for you to log in. Everyone can log in at the same time, and make sure to run this Hadoop fs command. Go through the list of commands you see there and run ls command, and make sure you understand the difference between local file system and HDFS. Okay, at least from the syntax perspective. Semantics perspective, I will explain how these files are actually stored, and then you will be able to understand why there are 270 tasks to process the data. So I'll be on mute for a minute. You just log in and start running this ls-ltr or Hadoop fs command, and then we will take it from there. To get the credentials for the lab, what you have to do, you have to log into the lab, get your username and password from here, and use these things to log into the lab, and then run Hadoop fs -ls as well as regular ls commands and see what you have. Okay, I'll be right back, or I'll be on mute and I will unmute after a minute. So everyone tried this? So if anyone in progress, just say that it's still in progress. I'll wait. Otherwise, I will start in next 10 to 15 seconds. Make sure you guys log in, and also when you raise any questions, mark it to everyone and ask the questions to everyone, so that even if I forget to repeat, at least the others will have some context. Also, I forgot to disable Wi-Fi. If my voice is not clear for any reason, just let me know. I will disable the Wi-Fi. Right now, I'm not disabling because it can disconnect something. So I'm just moving on. But anywhere, if you see any issue with respect to streaming, just let me know. So let's get into the let's dig further and try to understand what it is all about. So to demonstrate further, I have a directory called /data. This is local file system, and this /data is accessible to everyone, and you have read-only access on that. Okay, it's a soft link to this path home root data, but you guys can actually read all the files in that. So if I say ls-ltr/data/, it will give other files. In that we have a subdirectory called cards, and we have a file called largedeck.txt, which is approximately 720 MB. Okay, and also let me do tail on this data cards. There is a reason why I am doing tail. I just want to create a small file first, and then I will try to copy this 700 megabytes file. Okay, and I am saying tile -100 and hit enter. And I just want to copy these few lines, and I want to create small deck.txt and copy those 62 lines which I picked from there. Okay, let me E23D. Okay, and now I just have one deck of cards, a small file. Okay, and you can see it, small deck.txt. Now it's under local file system in my home directory, local to this gateway node. So I'm in home dgadiraju, which is local file system. In that I have file called smalldeck.txt. Now I want to copy this into HDFS. And for that, if you run Hadoop FS and hit enter, there are a bunch of commands. Okay, and we are trying to copy. So there are few commands related to copy. And if you see, there is a command called copy from local. Okay, and this copy from local, as the name suggests, is to copy files from local file system into HDFS. So copy from local, there are few additional control arguments. Don't worry about those things for now. We will actually cover HDFS after Scala and Spark workshop is done. I will try to cover little bit in more detail. For now, just to copy files, we just have to say copy from local. Local source means local path, and then destination, which is in HDFS. So here we have to give local path as first parameter and HDFS path as second parameter. So I want to copy using copy from local. The file is in the current location itself, which is which I am already in. So either I can say smalldeck.txt directly here. This is called as relative path. From the current directory, I'm trying to copy the files. Hence, we don't need to give the complete path. This is called as relative path. Or I can give fully qualified path. And I will highly recommend you guys to actually start using fully qualified path. It's the best practice to use fully qualified path as part of most of the applications. If you just give relative paths, then your program can lead into some confusions. So the best practice when it comes to dealing with paths in general is to use fully qualified paths rather than using relative paths. Okay, here I'm giving fully qualified path /home/dgadiraju, and in that I have the smalldeck.txt, and then I want to copy into HDFS user dgadiraju. So before this, let me actually make the directory. Okay, so first let me see what all directories I have. Again, I am running Hadoop fs-ls /user/dgadiraju. These are the directories I have. Okay, so already there is a directory called cards. So I'll be using this. If you don't have a card, if you don't have directory, and if you want to make a directory, you can also run Hadoop fs-mkdir /user/dgadiraju, because only in this location you have permissions. /user/your username, only in that location you will have permissions. So make sure you give your directory, or it is called as user space, and then try to create a subdirectory under that. with whatever name you want. If you want to use cards, you can create with cards like this. Now let me see what what I have in that location. Okay, user D Gadiraju. So there is only large deck.txt. Now let me actually add this small deck.txt to that directory. Okay, so I'm not running Hadoop FS mkdir because I already have directory. I am actually running copy from local home / user Digadiraju / cards. Okay, if I do not give the file name here under the cards directory, it will actually create with the same name as the file we are trying to copy. Okay, and here um, instead of just giving, even if you give it to this path only up to cards, because the directory already exists, small deck.txt will be copied to that location. If directory does not exist, and if you just say user Digadiraju cards, the small deck.txt will be renamed to cards under user Digadiraju. The file will be created using name cards. Okay, so you have to be a little bit careful. That's why using fully qualified paths will be a lot more helpful. Okay, in this, either you give the parent directory and then / and then dot to copy the file with the same name, or you can actually type the name also. It's up to you. Okay, and hit enter. I'm using a dot, and a file small deck.txt will be created in this location. Okay, Hadoop fs-ls. If I give that path, now you will see large deck.txt and small deck.txt. Size of the file is 693 bytes, and it is just copied, and the owner is Digadiraju, and group is HDFS. We will see a little bit of details about the file permissions and all those things when we actually dig into HDFS a lot more deeper after Spark portion of the course is done. For now, we at least understand how to copy data to that location. Now, if I want to run any program on this, how many tasks will be created? We will get into that. Okay, so I'm trying to create one more file here. Okay, just to simulate to run the word count program on the smaller data, and let me copy some text from somewhere. Okay, I'm getting some text about Spark itself. Okay, I can copy this one. I don't want to copy this. Yeah, probably this might be good paragraph. Okay, so vi word count .txt. I saved it and ls-ltr. You can see small file 415 bytes word count.txt, and now I am actually saying Hadoop fs -copy from local /home /Digadiraju /word count.txt to user Digadiraju. I'm directly copying into that location. Okay, now if I run Hadoop fs -ls on user Digadiraju, you will see this word count.txt also here. Okay, now if I try to run our Spark's job on this file, let us see how many tasks will be created, and then we will try to understand the logic. Okay, we'll dig further. So here I am running Spark submit. Okay, I will be using the other session which I have, because we already have the Spark submit command. Only thing is, my input path is now user D Gadiraju word count.txt, and the output path is WCOP2, and hit enter. Now the job is running. Let us copy this tracking URL. Okay, and hit enter. Okay, I don't know why I got one here, so let me delete this. It will work now. Now you see there are only uh, two stages. There are two stages, and now tasks are okay. There are two tasks. Okay, and then there are two executors, and in each executor there is one task. Okay, and each of them, how much data it read? So this first task actually read 745 bytes of data. Okay, 1 minute, let me go back again. Yes, stage 0. This is yeah, here you see wn01.itversity.com, which is first executor. It actually read 415 bytes of data, and our file is also of size 415 bytes. Okay, so the first task actually read the complete data. This 208 is actually the some metadata which it have read. So even though you can see that there are two executors, due to which there are two tasks which try to process the data, only one task actually read the complete data, the other task did not. Okay, the other task is created just because the default number of executors is 2. Now if I try to change number of executors as 1, let us see, actually it will fail, because the path already exists, the output path already exists. Most likely it will fail. Yeah, you see it actually failed. So let me change the output directory. And now let me copy this one. And now let us see. Okay, even now it actually creating 4 tasks. I think it's minimum number of tasks. We can actually change those settings to reduce the minimum number of tasks. Even though I say 1 at the command line, I think in the properties file, the minimum number of executors is 2. It's not only default, but the minimum number is 2. That's why at each level it is actually creating 2 tasks, but only one task is actually reading the data. Never mind. We will see. We will get into the details in a moment. Okay, so if you see, even though there are 2 tasks trying to read the data, only this one actually read the data. That can be confirmed by looking at shuffled right size or records. Here you can see there is we haven't this is not giving any output. Only this task is actually giving output of 745 bytes in size and 58 records. Because we are doing word count, there are 58 words in that paragraph, and only this one actually emitting that much. So if you see here, it has only one task is actually processing the data, other task is not processing the data. Why only one task? now you need to understand the way how the files are actually stored in HDFS, and how that actually determines the number of tasks that will be used to process the data. Okay, so for now we will be focusing on this file. So there are multiple ways to get the details about this file. Okay, one is using name node user interface. Okay, so the name node user interface runs under nn01.itversity.com:50070. So everyone can actually access this. Even people who don't have access to the lab can actually read this. It's open to everyone. And here you can go to utilities, browse the file system. But from here, people cannot actually go to the location and try to read the files because the permissions are restricted. There are some other ways you can use REST APIs to actually get the details, but we don't want to get into that. So if there are enough permissions, we can actually give the path over here, and then you will be able to see the files. Okay, and then if you go to Ambari, okay, here I'm logging into Ambari, and let me sign out here and log in as this user. And everyone will have access to this files view. You can click on that. Okay, and here we are in the root directory. We can actually go to user and search for our home directory and click on this. Because this is going through the authentication through Ambari, you will be able to access your files. And you can see this is the file which we are talking about. Let me see if I can get properties of this file. So I selected the file, and I can get permissions. Okay, I can open the file and click on permissions to get the permissions of the file. There should be a way to actually read the properties. I think this one does not provide you an interface to see the properties. When I say properties, I am talking about how the file is stored in HDFS. Through name node web interface, we can see. So let me go to the name node web interface here by using this URL nn01.itversity.com:50070. You can also try to access this. Okay, and then if you go to utilities, browse the file system, the public one which is accessible to everyone, you guys can use public. Click on cards, and here I have largedeck.txt, and you can see there is a very important there are a couple of very important parameters. One is block size, and second one is replication. We will get into replication a little bit later, and this is very important, and this is what makes your file system distributed. So what is HDFS? HDFS is nothing but a Hadoop distributed file system, and the way it will distribute the files is based upon this block size. Now if I click on this largedeck.txt, it will give the properties of that file. Okay, when I say properties of the file, it will tell you how the file is stored in HDFS in distributed fashion. So here we are talking about a file of size 693 MB, and the block size is 128 MB. Okay, now if you divide 693 by 128, how much you will get? 693 divided by 128, it is 5.4. We have to take the seal. Always we have to take the seal. Hence it is 6, and there will be 6 blocks associated with that file. So if I click on largedeck.txt, here you will see 6 blocks: block 0, block 1, block 2, block 3, block 4, block 5. This is nothing but just logical index about which block in the file. So it's in a proper order. Block 0 will have the first 128 MB, block 1 will have second 128 MB, so on and so forth, and block 5 will have the last portion of whatever size it remains. So now we can say that the file is divided into 6 blocks, and these 6 blocks are actually stored in HDFS. Where they are stored, you can see the section called availability, and these are nothing but our host IP addresses or host DNS names, which will resolve into IP address of the slave nodes. So this block 0 actually have 3 copies of it, and those 3 copies are on WN01, WN03, and WN02. If you go to block 1, the size is same, almost similar, 128 MB, but it will have, it is second 128 MB of the file, and the first copy is on WN03, second copy is on WN02, and third one is on WN01. And if you focus on block ID, it will be changing for each and every block. Here it's 10738595557. Here it is 103859558. And you see for every file it will change. And if you go to the last file, last block, this is the block ID, and this is the size of it. It's only 50 MB. And here are the three IP addresses where the block is replicated. So the purpose of this having 3 copies is, even if one of the nodes goes down, still there are 2 other nodes, the data where the data is available, so there won't be any data loss for you to do the processing. So for fault tolerance and reliability purposes, it is actually using this replication and actually creating 3 copies of each and every file, and these are default values, and we can override. Yes, it can be changed in the configuration files. We'll get into configuration files in a moment, and also we can actually change while copying the data into HDFS also. Okay, so now I have this large deck copied in my location, which is user dgaziraju cards. There is a very handy command which can be run at command line, and we can get all the data which we see as part of this HDFS web interface using command line, and that command is HDFS FSCK. Okay, this is not Hadoop FS, this is HDFS FSCK. FSCK stands for file system check, and HDFS is primarily a tool for administrators. Developers typically don't use, but I will highly recommend that every developer are familiar with the HDFS FSCK command, and it will take the input path. So now let me give the path, and then if you just want, you can either give directory or files. It's up to you. If you just give up to here, it will try to get information about all the files in that location. But I have given the file also, and then I can run files to get the name of the files in the directory. As we have only one file matching our file name, you can see total number of files is 1, size is 415. If you want to get to the block IDs, which are unique across all the files, if you want to get the details about blocks that are associated with this file, by running files itself, we can see that there is only one block associated with this file. Okay, if you want to get the details about the blocks, such as block ID, you can say -files -blocks, and here you can see the details about the block ID. Okay, so this is the block ID. Okay, actually this is the block ID, and then there is some other metadata added to it, and it is showing up this, but this is the block ID, which is unique across all the blocks with respect to all the files in HDFS. And here it did not give the location. If you want to get the location, you can also say locations and hit enter. And you can see the file have one block, and that block have 3 copies, and all the 3 copies will have the same block ID. And the first copy is on this host. You can see the IP address of the host of the first block, and second first copy of the block. Second copy is on this IP, and third copy is in this IP. But there is only one block. Because there is only one block for this file, it has actually used only one task to process that data. Now let me show the metadata for this location. Okay, where we have 2 files, largedeck.txt and smalldeck.txt. So if I want to run HDFS FSCK on this and give the path of the directory, user /dgadiraju/cards, and save files, it will give the details of the files. There are 2 files. There's only one directory in that path, and there are 2 files, and total number of blocks are 7. Okay, and you can see 6 of the blocks are related to the largedeck.txt, and 1 of the block is related to the smalldeck.txt, which is offset 693 bytes. Now if I want to get the blocks and block locations, I just have to say blocks and locations. This is the sample command which you can use. So I'm pasting in the chart, and I will give you a task in a moment, and use this command as template at the time, and try running finishing the task. Okay, and files, blocks and locations. First, it is showing the largedeck.txt. It has 6 blocks, and you can see the information of all the 6 blocks here. And then another file with 693 bytes, which have 1 block, and 3 copies of it. Okay, so everything related to the files and blocks are shown here. Now if you want to get the details about the files which I'm passing as input path for my original word count program, what is our input path? /public random text writer. Okay, so now every one of you try to use the command which I have given to you, and run one at a time. Don't run everything in one shot. Try to run files first, and then files and blocks next, and then files, blocks and locations on this path. Okay, and then see what are the total number of blocks and other information. The main thing which you need to focus is total number of blocks. I will give 1 minute, and if you run into any issues, just let me know. I will try to fix it. But make sure that every one of you run the HDFS FSCK command. You have to change the path to this, and then you have to give -files. First give -files and see what is the information it will give about files, and then files and blocks, and then files, blocks and locations. Okay, so there is one question from Abhishek. Is it possible to check data in the block? Will it give the data? So you cannot actually check the data in the block. It is not possible. You have to access the files only through the file names, which is this one. Physically, you can see where these blocks are stored and all, but if you try to read that, it will be in binary format, so you will not get much information. Okay, for that you need to have access to other nodes. As you don't have access, you will not be able to check even the files. Okay, so first finish off this exercise, then I will our task, then I will show how these files are actually stored in the form of blocks physically. You need to understand this term physically. Okay, from HDFS context, all the file names are just logical. Okay, the physical, the term used to, the term which we should use um, uh, uh, to, or the term which actually physically represents these files is nothing but block. So block is the term which we should use from the physical aspect of storage of these files. Otherwise, these file names are just logical names. Okay. So for now, it is very important to run this HDFS FSCK command. Our input path is public random text writer, and then give files, blocks, and locations. And please confirm. And I'm expecting answer from everyone. You guys can ping in chat. What are the total number of blocks? The output will show how many blocks are there, and just paste it in the chart. So anyone ran the command HDFS FSCK? Public random text writer. Everyone has to log into the lab first. Only from gateway node you will be able to see these details. And then hyphen files. Once you understand information thrown about files, you can give blocks and also locations. You can type this command, and you should tell me the number of blocks in this directory. Number of blocks associated with the files in this directory. So Srinivas have given the answer. I hope everyone run this command. I'll wait for another 30 seconds. If you want some more time, let me know so that I can wait. So one more answer I got from Abhishek. "20 more seconds. Avinash also responded. 15 more seconds. If you just need more time, just ping me in the chat. I will wait. Or even in the Skype. Wavelabs guys, you can actually ping in chat also, Skype also. Okay, now I'm getting answers from many people. So 10 more seconds. 5 more seconds. And you see, I think everyone got this. Total blocks is 270. And now I hope you guys can relate why there are 270 tasks to read the data from HDFS and apply the initial flat map and map logic on them. I hope everyone is clear about it. If anyone is not clear, just let me know. I will try to explain. Okay, so it is nothing but total number of blocks that drives the number of tasks that will process the data. Can we change this? Yes, we can change it. There is a parameter called map reduce input format split size or something. I do not remember exactly on top of my head. If you increase it to 256 MB, by default, the split size is same as the block size, which is 128 MB. And with 128 MB, for all these files, we have 270 blocks. If we change the split size to 256 MB, there is a possibility that it will actually reduce the number of tasks. Anyway, don't worry too much about it. Let's just focus on the default behavior and let's proceed further. We'll talk about how to play with the number of tasks to process the data a little bit later, or when we actually talk about HDFS in depth. Okay, so now let me. So Prasad mentioned that replication factor can be changed in the config files. Now let me get to that point. So how this gateway node know about the cluster? Okay, so the way it will know is if you get to the gateway node and go to this location /etc/ in this there will be a bunch of directories where there will be bunch of configuration files. When it comes to big data tools such as Hadoop, Hive, Pig, etc., for each of these things there will be a subdirectory. For Hadoop, there will be a subdirectory called Hadoop under etc, and then there is another subdirectory called conf. Okay, so now if you see, I am under /etc/Hadoop/conf. Here, if I run ls-ltr and hit enter, there are a bunch of XML files, properties files, which will control the behavior of HDFS and MapReduce. And the main files which will actually control the behavior of HDFS are coresite.xml and hdfs.xml. So these two are the files which will control the behavior of HDFS. Okay, HDFS is nothing but Hadoop distributed file system. First, we need to understand the architecture of it. Again, we will get into those details when we talk about HDFS in detail. For now, we just focus on how to copy the files into HDFS and how to read those files from Spark programs. That is good enough. When we actually get into HDFS after the 3 weeks, we will actually get into a lot more details about HDFS. For now, just understand that these are the parameter files which will control the behavior of HDFS. And here, if you go to coresite.xml, it will have a very important parameter called fs.defaultfs, which will be pointing to the name node IP address and port number. So using this information, our gateway node can understand where our cluster is. If you have access to name nodes, you will be able to understand our Hadoop cluster easily. Okay, even if you go to this web interface, which I have shown earlier, we have gone into utilities and try to get the information about the files. You can also click on overview and you can see more details about the cluster, how many live nodes are there, what are there, by clicking on this link. And you can see WN01, WN02, WN03 are the worker nodes or slaves for our HDFS. So using name node, you can actually get the rest of the information about the cluster. Okay, and then if you go to hdfs-site.xml, in that you have this dfs.block size, which will control the block size, which is 128 MB by default. Okay, and with respect to replication, you can say dfs.replication, and you can see the replication factor is 3. You can also access these properties through Ambari. Okay, Ambari is nothing but management tool. I already have another tab here. So click on dashboard. We are talking about HDFS. You click on HDFS, go to configs, and here the representation of the parameters is a little bit different. From command line, you have to go through files, and the data from those files is grouped into typical settings and advanced settings. And if you want to search values for a particular parameter, you can actually start typing here. So let's look into default FS, and you see fs.default fs, which we have seen from coset.xml. You can see the value of it here. Similarly, if you want to get the block size, you can just start typing block size, and this is the parameter name and this is the parameter value. You can also see the replication, and the replication factor is 3. So here they gave a little bit tradable name, but the actual parameter name is, now you can see on the right, actual parameter is nothing but dfs dot replication, and 3 is the value. Okay, so here I will give some time for you to, again, probably 2 minutes or 3 minutes. Now it's 3:40. Let's wait until 3:43 or 3:44, and you go to this location, etc hadoop conf, look into code side dot and hdfs side dot xml, try to review these parameters which I have explained, and also go to Ambari, click on HDFS, go to configs, and try to get the information from here. As developers, you should not touch these files either from command line to modify, or from web interface to modify. Even if you have permissions to do so, you should not do that. It should be the administrator's task, and it has to go through the standard process of your organization. It has to go through change control to make these changes if you want to override any of these things. Okay, so try to explore from both command line as well as the web interface. For web interface, go to Ambari, use your lab credentials to log into the Ambari, and then click on HDFS and try to get these details. So I will wait for 2 more minutes. So I hope everyone have verified. If not, let me know. I will give some more time if you need some more time. Okay. Now, can we change these things at runtime while copying the data? Yes, we can. So I will show how. So let me actually copy this. Let me delete this, or let me run fs-get. Fs-get or copy to local. This command will actually get the data in HDFS to local file system. So which one I want to copy? /user /dgadiraju /cards, and I want to copy it to local file system. So it will create a directory called cards, and it will copy both the files locally. Okay, and then there is this cards directory, and now I am actually deleting this directory in HDFS, and I want to override these parameters, block size as well as the replication factor. Block size I want to change it to 64 MB rather than 128 MB, and the replication factor I want to change it to 1. Okay, and to do that, let me get the DFS block size here. Block size is 128 MB. So I'm pasting it here and dividing by 2. So 64 MB is 67,108,864. Okay, now I can say Hadoop FS to override any parameters at runtime without modifying the files. To modify the files, it has to go through administrator. But without going through administrators, if you want to change certain things, certain behavior at runtime, you can use -D and then dfs.block size. And the block size I want to give it as 64 MB, which is 67,108,864. Okay, and then I want to give the replication also. I want to change the replication to 1. And then I want to copy from local. So copy from local starts with hyphen, copy from local. Cards is the directory which I want to copy, and the target location is user dgadiraju, and hit enter. Okay, and also let me copy to this location, public hit enter. Yeah, so you can run this command by yourself. So I am trying. Let me see if I have the cards in this location. Data cards. We have it right already. We have it here. So every one of you run this command. Okay, but make sure instead of just cards, you have to give /data/cards. Okay, because you are trying to copy this directory into HDFS under your home directory, and then instead of /user /dgadiraju, you have to give your lab ID after /user to copy to your location. So you can run this command. I'm pasting as part of the chart. Okay, so here I'm giving you 2 tasks. Run this command and copy the cards directory, which have only 1 file. Let me copy a new file also into that. CP home. Don't run yet. Let me copy this small deck to data cards. So now even data cards have 2 files. So use this location and try to copy into HDFS to your directory using these 2 parameters. Overriding these 2 properties. One is block size and second one is replication factor. So run this command. That is the first task. copy files from data cards to your user space or to your home directory in HDFS. And the second one, run HDFS FSCK command to get the properties of the files, and tell me how many blocks are there. How many total number of blocks are there under the location /user /your OS user ID and cards. On this, you have to run HDFS FSCK, and you have to tell me the total number of blocks. And also total number of copies of each block. So you have to run these two commands and paste the output. Don't paste everything, just paste the total number of blocks and copies, number of copies you have. I'll give 2 more minutes for that. And at any point in time, if you need more time to finish these tasks, just let me know. And also, if you are running into any issues, just let me know. I will fix them immediately. Okay, anyone ran the commands? Are you able to at least copy the files? I'm also pasting in the chat. So I'll give 1 more minute. If you want me to wait, I will wait. And this is the FSCK command example. Okay, so Madhuri is trying to run CP command. I didn't ask you to run CP command. I asked you to run copy from local after Hadoop FS. And here, instead of saying cards, it should look like this. Okay. Data cards. So this is the command which I have asked you to run. And I'm not sure which location you are in when you run the CP command, due to which it is causing the issue. Okay, if you can run pwd command Madhuri and show the output here, then I can confirm whether you are in the right location and why it is failing. Okay, so I didn't ask you to run CP command. Instead, you should run copy from local to copy data from local file system into HDFS. Yeah. So you are in the root directory. So here I think you are new to Linux. Okay. So you are in root directory. Okay. And if you understand the Linux file system, root is owned by so this just slash is owned by root. Only root can do anything he want in that location. Anything other than root, if they have to do it, do something in any of the subdirectories under that, they need to have permissions. In this case, you will not be able to copy whatever you want into this root file system slash. You have to be in your home directory in Linux if you want to copy files to your file system. So instead of being in a root file system, which is just a forward slash, just type cd and go to your home directory and then type cp data cards. And also you have to, here you are trying to copy the contents of the directory. So you have to use cp-rf, R for recursive, F for files, and hit enter. Now those files will be actually copied to your home directory. Okay, now I can say ls-ltr, and just now the files are copied, and you can see these files. Okay, so you are in, you will not be able to run it over there. So some people actually pasted output. Okay, Rekha actually ran both copy command and fsck command. Just tell me the number of blocks. Don't paste the entire output. Just to tell me the number of blocks. Himanshu actually ran it already, but it is saying total blocks as 0. No, Rekha, it should not be 6. Okay, so let me see. It should be more. HDFS FSCK. So I am exiting out of it and then sudo su Rekha. Okay, now I logged in as Rekha Goyal, and then if I run HDFS FSCK command, total blocks it is showing as 6. Okay, so here there are plenty of other files which are copied. So let me understand what you have ran. So first you try to run this command hadoop fs -dfs dot block size 64 MB replication 1, copy from local, home Rekha Goyal data cards. So let me see data cards. Okay, so here there is there are different sets of files. Okay, that's why there is a gap. What I have mentioned, I asked you to copy stuff from data cards which have only 2 files, large deck.txt and small deck.txt. Copy from this directly. Delete your whatever stuff you have by running hadoop fs -rm capital R user Rekha Goyal. I'm deleting cards directory from here. Now rerun again, and when you run HDFS FSCK, run it on user Rekha Goyal cards, and then you will see the output. And I'm seeing the output of Himanshu. It is not actually correct. I think you haven't copied. I don't know which directory you are copying to. So let me demonstrate from my user itself. Okay, sudo su d gadi raju. So which files I want to copy? I'm trying to copy data cards. Okay, from there I have ran this 1 minute. I think I have ran this command already with the block size and replication factor. And now if I run hadoop fs-ls/user dga-diraju, I can see the directory called cards here. Now I'm running HDFS fsck, this path, okay, and then files. So files gave 2, number of files are 2, and total blocks is actually 12. Okay, so 11 for our 693 or 683 MB file, and then 1 for our 693 bytes file. Okay, if from this what you need to understand is, if the file size is less than the block size, it will always be associated in a unique block. It will not be mixed up with other blocks of other files. So in this case, there is one block for this smalldeck.txt. That's why I have small file also in that directory. And then largedeck.txt actually split it into 11 blocks. Okay. Now, if I actually go to the blocks and locations to get the details about blocks and locations, you see replication factor of each of the block is only 1, means only 1 copy is there, and you can see there is only 1 entry associated with each block, because our replication factor is 1 when we try to copy the data. So now the question is, if I want to change the block size or replication factor of the existing files in HDFS, can I do that? Can I change the replication factor and block size for the files which are already there in HDFS? The answer is, with respect to block size, we cannot change, because it has to recopy again. I mean, if you now want to change it to 128 MB back, again, if your file has to be reformatted or resplitted with 128 MB as the block size, which is not straightforward. Hence, you cannot actually change the block size of the existing file. If you have to change, you can run a cp command to copy the file with different replication factor, different block size. But when it comes to replication factor, there is a command called, under hadoop fs, there is a command called setrep. And using this setrep command, you can actually change the replication factor. Now, if I want to change the replication factor to 2 on this directory, we can actually say fs-help and setrep, and you will get the syntax and all the other details using because of the help command. Now I can say hadoop fs setrep, and here I am giving the path user dgadiraju/cards. Okay, and I think after giving the, okay, first I have to give the path, not after. Sorry, first I have to give the value, not after. First value and then the path. Instead of 1, now I am changing it to 2. Okay, now the replication factor is changed. And now if I run HDFS fsck, files, blocks, locations, you can see average block replication is 1.41, because it's still in progress. Okay, it will not be immediate. We will see. We will run again, and you can see now the block replication is changed to 1.8, because even though the command came back immediately, the underlying copy is not done yet. Okay, probably by now it might have changed. Yeah, now you can see that for each block there are 2 copies associated with it, and you can get the IP address and other details for each of the block using HDFS fsck command. But if you want to change the block size itself, you have to at least run cp command to copy from one HDFS location to another HDFS location, and we will see that later. Okay, so we will wrap up in next 2 minutes. for today because I have to travel, and we'll catch up on Thursday. But I will take few questions if you have any. If you don't have, I will pause here. And I hope now it is clear why the 270 tasks are running to read the data and apply map and flat map. And to control on the reduce by key side before saving into the file, there is a way. By default, it uses the same number of tasks that are used by that are used to read the data based upon the size of the data. Even the reduce, the second stage also, it will try to use the same task when it comes to Spark. But most of the times that value is not appropriate, and you should know how to change that. And I will explain later, probably as part of the next class. But at least at the first stage, now we understand why the 270 came into picture and why there are 270 tasks trying to process the data after reading from the file system. We will understand, we will dig deep about second stage little bit later. Okay, this is a very brief introduction about HDFS. Here you should know about Hadoop FS, and if you get time, just go through all these commands and start practicing those things. We will see those as many as possible when we actually talk about HDFS in detail later. And then focus for now, focus on important commands such as copy from local, copy to local, whatever commands I have used as part of this today's session. mkdir to create the directories, HDFS fsck command, and this will give some expertise in HDFS. Okay. So Abhishek is asking, can you show the block stored physically on the data node if possible? Yes, you will not be having access to that, but I will show. So we ran this command HDFS fsck on user D Gadraju cards a little bit while back, and here you can get the block ID. Let us see one of the blocks. So this is the block ID, and let us see on which worker nodes we have these files. We have it on 104 and 103. Okay, the physically stored blocks. So I will be logging into one of these nodes, 104 or 103. Let me run cat on etc hosts. So in my case, 103 is WN02 and 104 is WN03. So I am logging into one of those nodes. Okay. And then if you go to Ambari or even to command line, if you click on HDFS, go to configs, there is a parameter called DFS data node data dir, which will control where our files will go, which are nothing but physical files associated with the blocks. Okay, so in this case, these are the this is the location HDP01 and HDP02. I have two hard disks mounted onto that. So now I am logged into one of the nodes which have the file. I copied the block already. Now I can go to the root file system and then run find command from here by name, the block ID, and hit enter. So instead of giving the entire file system, let me narrow it down a little bit. I hope you guys are familiar with find command. If not, I will talk about it later. So our file system actually start with HDP01 and HDP02. So it could be on one of those hard disks. So I am giving HDP star to go through both the hard disks or mount points for the file with name with this block with names having this block ID in it. So here you can see, so this is the actual file for that block, which is associated with largedeck.txt. Okay. Apart from that, you will not be getting any information from this. You don't know to which file this block is related to. Also, only through name node you will be able to get the mapping between the file name and the physical files. Okay, so this is how the files will look like if you try to cat or view. Okay, I think it is stored in as regular files itself. I thought it will be in the binary format, but yeah, if it is text file, I think it will just store as is. So you can actually see the contents, but this one have only 164 MB of the entire file. Okay, and this .meta file will have the metadata associated with that block. So we can run view on it. Here, this is all in binary format, so we don't know. We cannot interpret that, but what it will have is all the information related to the block to confirm, such as properties of the file and few other things. We will see that when we actually dig into HDFS later. Okay, any other question? So I will take one more question and then I will wrap up for today. Okay then, thank you very much, and we'll catch up on Thursday. Have a nice week ahead. Until then, thank you. Bye. And those who are on Google Hangout, thank you very much for joining the session. As I have emphasized earlier, this is the backup for the live training, so I will not be able to take questions from you. But that being said, if you have any questions, and also you can keep on working on these tasks. If you have any doubts with respect to tasks which I'm assigning as part of the videos, you can go to discuss.itversity.com and start writing the questions over here. There are an army of volunteers who are taking care of the questions. You also can be part of it. You can also answer others' questions and make it bigger in future. And if you need environment to practice and to use discuss.itversity.com, you don't need to be part of my live trainings. You don't need to be part of my lab. You don't need to pay anything for me. You can ask any questions on discuss.itversity.com. We'll keep on adding more and more categories going forward. And then if you need environment to practice, you can sign up for our lab. Our lab URL is labs.itversity.com. These are the plans. It's $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. You can choose one of the plans and enroll for the lab if you don't have environment. But to ask any questions, you don't need to subscribe even for the lab. You can ask any questions at any point in time. And before we wrap up, if you like this video, please click on the like button of the video. And if you want to share with your friends, please click on share, and then you can share with your friends. And that will help me to reach out to more and more people. As I have been saying, if I get enough subscribers, I'll be expanding the lab to bring each and every tool under the hood of big data into the lab as complimentary for you at the same cost. Probably I might add sales tax here and there, but there won't be any significant difference in the cost. Yet you will be able to access the entire big data ecosystem as we get more and more subscribers. So please spread the word and try to get more folks onto the lab, and I will try to come up with a fully sophisticated, full-blown lab with all big data related tools as part of it. That being said, thank you very much, and we will catch up on Thursday. Bye.